Recently, astronomers celebrated a very important anniversary, that of the James Webb Telescope. A birthday that deserved to be celebrated, because it is not a telescope like any other. Developed by NASA, with the participation of the European Space Agency and the Canadian Space Agency, the James Webb is nothing less than the largest and most expensive telescope at the time of its launch. The James Webb was launched on December 25, 2021. Within a month, the telescope reached its orbit, 1.5 million kilometers from Earth, or about 900,000 miles from Earth. After a first image published in July 2022, the James Webb revealed images, all more impressive than the other, which allowed astronomers to make beautiful discoveries. Dear traveler, welcome. Today we are going on a dizzying journey into space, guided by the discoveries of this record-breaking telescope. But before leaving for a new adventure, think about liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. Before you set out to explore the universe, you need to understand what makes the James Webb Telescope so special. The project took over 30 years to complete. That's right, work on the telescope began in 1989. And again, everything was almost canceled in 2011 when the original launch date was set for 2013. But why did it take the scientists so long? Simply because the design of the telescope has met many technological challenges, not to mention the pharaonic budget overruns. The cost of its manufacture, estimated in 2005 at $3 billion US, finally reached $10 billion. 10,000 people worked on the project, and some scientists even devoted their entire careers to the design of the James Webb. This is not really surprising when you know that it weighs more than 6 tons and that its heat shield is the size of a tennis court. Fortunately, for science and astronomy, the telescope finally saw the light of day and was launched by the Ariane 5 rocket on December 25, 2021, from the Kourou base in French Guiana. It was then placed in orbit around the Lagrange point, called the L2 point, 1.5 million kilometers, or 900,000 miles from Earth, on the opposite side of the Sun. You will see that this positioning is crucial for the survival of the telescope in space. The launch of the telescope was somewhat delicate. In order to fit into the Ariane rocket's noise cone, which measures 5 meters in diameter, the telescope had to be folded, hence its nickname of origami telescope. The main mirror was divided into 3 large portions, and the sun shield was folded. What was stressful for the scientists was that James Webb had to unfold itself without any possibility of intervention. This was a first, because its predecessor, Hubble, had benefited from several space missions to be repaired. The mission of James Webb was fixed at 5 years, but its energy reserves will allow it to maintain its position at the L2 point for at least 10 years. By the time the telescope completes its mission, there will be some great images. The interest of the James Webb Telescope is that it can make images in the infrared. The infrared radiation of stars, planets, and galaxies is crucial for understanding space, but the Earth's atmosphere blocks some of it. Therefore, it is not possible to observe in the infrared from the Earth. The IRIS infrared telescope, placed in orbit by NASA in 1983, was a pioneer. That is why, when scientists started thinking about the design of the James Webb Telescope, they naturally wanted to design a powerful telescope, optimized for infrared observation. The launch of the James Webb Telescope serves many purposes. During its mission, the James Webb will focus on the first galaxies, those that appeared just after the Big Bang, to observe their diversity and understand their formation. It will also study exoplanets and their atmospheres, looking for biosignatures that could indicate extraterrestrial life. It will also observe the black hole, Sagittarius A, located at the center of the Milky Way, to complete the images produced by an array of telescopes in May 2022. The James Webb Telescope design project was initiated to replace the Hubble telescope, launched on April 24, 1990. While Hubble focuses primarily on visible light, the 4 science instruments of the James Webb are designed to capture infrared light in particular. On March 3, 2016, a Hubble image was released that discerns the galaxy GN-Z11, located 13.4 billion light-years from Earth, the most distant galaxy ever observed. But we can only see a shapeless red spot, because the more distant a galaxy is, the more red it appears on our telescopes. This is the phenomenon of redshift. The universe is expanding. The light waves are stretched. The closer an object is to us, the more the light waves are compressed. It will therefore appear bluish, because the short light waves are blue. On the contrary, the further away an object is, the more the light waves will expand. The longest visible wavelengths are red. The instruments aboard Hubble can distinguish a part of these infrared waves, but not further than 500 million years after the Big Bang. James Webb was therefore designed to see further into the infrared range, and thus into the past. The observations of the James Webb are focused on the near and mid-infrared. Unlike Hubble, it can observe neither the ultraviolet nor the entire visible light spectrum. It therefore studies wavelengths from 0.6 to 28 micrometers. Because it is difficult to capture the light of very old galaxies, the James Webb is placed in orbit 3,000 times further than Hubble. It is placed in orbit around the Lagrange point for a simple reason. In the infrared, we observe any object that gives off heat. However, we do not want the James Webb to capture its own radiation, or the thermal energy emitted by the Earth, the Sun, or even the Moon. The side of the telescope that faces the Earth and the Sun could rise to 110 degrees Celsius, or 230 degrees Fahrenheit, without its sun shield. However, this one, as well as the positioning of the telescope's orbit, allows it to maintain a temperature of about minus 240 degrees Celsius, or about minus 400 degrees Fahrenheit. If the sun visor were a sun cream, it would have a protection index of 10 million. But what are we trying to observe in the infrared? Astronomers hope, above all, to improve their knowledge of space. The process of formation of the first stars and the first galaxies after the Big Bang, the processes that govern the evolution of galaxies, the genesis and composition of supermassive black holes, the composition of the atmosphere of exoplanets. It must be said that astronomers have put a lot of effort into understanding the mechanisms of the universe. The James Webb is in itself a real technological feat. It is equipped with a huge mirror of 6.5 meters, or 21 feet, in diameter, which will concentrate the light received, and 3 imagers and a spectrograph to capture and analyze it. These measurement tools, which require a low ambient temperature to operate, are protected by a huge sun shield the size of a tennis court. The telescope moves around the Lagrange point at a speed of 1 kilometer per second and circles it in 6 months. It also accompanies the Earth in its movement around the Sun, and thus goes around it in 365 days. A little more than a year after its launch, the James Webb Telescope has already exceeded all expectations. It has revealed unprecedented images of nebulae, for the first time visible with such quality of very distant galaxies and stars. It also provided unprecedented images of planets in our solar system, such as Jupiter and Neptune, which had never been photographed with such precision. Astronomers are pleasantly surprised. The James Webb did not encounter any technical problems, and its instruments are even more efficient than we had hoped. The images you are about to see, which were produced by the James Webb, are normally invisible to the naked eye because we cannot see in the infrared. These images have been colorized by astronomers so that they can be appreciated by the general public. You must be eager to discover them, so here we go. The first image from the James Webb Telescope was unveiled on July 12, 2022. It is a photograph of the galaxy cluster SMACS 0723 as it was 4.6 billion years ago. Described by NASA as the deepest and sharpest infrared image of the distant universe to date, this image is historic. Yet it's not really the deepest image ever, since the Planck satellite photographed the cosmic microwave background, the oldest photons in the universe, in 2013. Returning to the first James Webb image, SMACS 0723 is a compact cluster of galaxies located more than 4 billion light-years from Earth. The photographed area is actually no larger than a grain of sand. Amazing, isn't it? This image is impressive for its precision. 19 galaxies can be seen instead of the 5 observed by Hubble. But not only, it also illustrates an effect of general relativity described by Albert Einstein, the gravitational lens. The gravitational lensing effect is the deflection of light by a mass, planet, galaxy, or cluster of galaxies. More concretely, when a very massive celestial body is between an observer and a distant light source, the gravitational lens deflects the light rays that pass near it and distorts the images that the observer receives. Because of the lensing effect, 14 of the 19 galaxies are tripled in the image, 2 are quadrupled, and one of them even has 5 images. The first James Webb image, because it is sharper and more detailed than any of the images provided by Hubble, may help scientists measure the ages and masses of star clusters within distant galaxies in order to build more accurate models of the galaxies that existed in the cosmic springtime, that is, in the distant past when galaxies were active, interacting, and merging with each other, and had yet to expand into larger spirals. After this first deep field image, the telescope continued to make new discoveries. One of the important discoveries of James Webb concerns the exoplanet WASP-39b. The data transmitted by the telescope on this planet show the presence of CO2 in its atmosphere. This is not only the most detailed analysis of an exoplanet's atmosphere to date, but also the first time CO2 has been detected. Located 700 light-years away in the Virgo constellation, WASP-39b is a hot gas giant that looks a bit like Saturn and is a quarter the mass of Jupiter. It orbits even closer to its sun than Mercury does to ours. When the exoplanet passes in front of its sun, the light of the star passes through its atmosphere, which allows scientists to study its spectrum and thus its chemical composition. Carbon dioxide was thus identified, a first outside the solar system. But if this molecule is linked to life, it is obvious that WASP-39b is uninhabitable. It is a gaseous planet, and the temperature is more than 870 degrees Celsius, i.e., almost 1600 degrees Fahrenheit. If this discovery is so exciting for astronomers, it is because it shows us that it is possible to detect CO2 on other planets than those of our solar system, in particular on rocky exoplanets that would have characteristics more similar to those of the Earth. James Webb has not only detected CO2 in the atmosphere of WASP-39b, but also sulfur dioxide, SO2. It is again the first exoplanet where this molecule is detected. Decidedly, WASP-39b beats all records. The SO2 would come from a chemical reaction produced by the high-energy photons sent by the star. In other words, a phenomenon of photochemistry as on Earth. As a reminder, photochemistry is involved in photosynthesis. James Webb was able to note other particularities of this exoplanet. The clouds of its atmosphere would be in pieces rather than in uniform coverage, and the atmosphere contains neither methane nor hydrogen. It does contain sodium and potassium and water vapor. All these observations are crucial to better understand the chemistry that governs the atmosphere of exoplanets. Astronomers hope, by better understanding the atmospheric evolution of exoplanets, to establish models of formation and evolution of these stars. Regarding WASP-39b, scientists were able to trace its formation based on data transmitted by the James Webb. It would have been formed by the collision of very small rocky bodies, which merged to form an exoplanet. During its evolution, the planet would have then approached its sun. On July 12, 2022, the James Webb Telescope also transmitted an image of the Carina Nebula. In the colorized photograph, it looks like a landscape of mountains and valleys speckled with twinkling stars. In reality, it is a young star-forming region in the Carina Nebula, which has been named NGC 3324. This nebula had already been photographed by Hubble, but the images were much less precise. A nebula is an interstellar cloud of gas and dust. Nebulae are bright, either because they radiate light from the gas that makes them up, this is called an emission nebula, or because they reflect the light of stars, this is called a reflection nebula. But there are also dark nebulae, which are not illuminated. Until the 1920s, the term nebula was used to describe any celestial object of diffuse appearance. But scientists realized that some objects had a diffuse appearance only because of the observation instruments used. Since then, the term nebula designates regions of the interstellar medium, particularly rich in gas or interstellar dust. Nebulae are formed following the explosion of a supernova, which will project debris into the universe. This debris forms a cloud of gas and dust, the nebula. The Carina Nebula is located at 7,600 light-years from Earth. It can be observed in the sky of the southern hemisphere. It is considered a bit like a nursery of stars. In this nebula, stars are born and die constantly. Recently, NASA announced that it had discovered a buried treasure in the image produced by the James Webb. Particularly young stars, whose analysis could help astronomers understand the processes leading to the formation of a star, like the Sun. Because the precision of the photo allows us to see even the dust disks that precede the appearance of a star. Nebulae are conducive to the birth of stars. Under the effect of gravity, gas and dust come together and form a ball. The gases in this ball rotate very quickly and increase the heat. A nuclear reaction will then occur. The ball of gas is transformed into a star. On September 12, 2022, the James Webb Telescope revealed an image of the Orion Nebula, the closest nebula to us, also called Messier 42, or M42. Located in the Milky Way, about 1,350 light-years from Earth, the Orion Nebula can be viewed from Earth with a telescope or refractor. One can even observe the trapezium cluster, the brightest section of the nebula, with binoculars. On the photograph taken by the James Webb Colorized, we can observe in a very precise way the Orion bar, a wall of gas and dust which is inside the nebula. The two brightest stars in the photograph, just in front of the Orion bar, belong to the trapezium cluster. These stars were born in the Orion Nebula 300,000 years ago. They are hot and massive, and their intense ultraviolet radiation disrupts and shapes the entire surrounding landscape, slowly eroding the Orion bar and sweeping away the less dense filaments. On the pictures taken by Hubble before the James Webb, we could see less clearly that the brightest stars of the trapezium cluster have even dug a huge cavity in the nebula. The James Webb allows more precise images because, as it observes infrared light, it can see through the layers of dust that obscure the nebula. The image also shows a cocoon of a star with a protoplanetary disk, 40 times the size of the distance between the Earth and the Sun. Conditions similar to those that allowed the birth of our Sun and its planets 4.5 billion years ago. The picture of the Orion Nebula would be, as that of the Carina Nebula, very important for understanding the formation of our solar system, especially since, according to researchers, when the universe was half the age it is now, the most numerous galaxies were the starburst galaxies, which contain nebulae similar to the Orion Nebula. Another nebula image was released by NASA on September 6, 2022, a shot of the Tarantula Nebula, also known as 30 Doradus, located 161,000 light-years from Earth in the large Magellanic Cloud dwarf galaxy. The Tarantula Nebula is the largest and most luminous star-forming region in the entire group of galaxies not far from the Milky Way, and is home to the hottest and most massive stars known. In this region of the universe, stars are born at a dizzying pace. The Tarantula Nebula is particularly interesting for astronomers. Its chemical composition is similar to that of the gigantic star-forming regions that could be observed when the cosmos was only a few billion years old, at the peak of the star-forming era. The picture taken by the James Webb reveals, thanks to the NIRCom instrument, the near-infrared camera, thousands of young stars never seen before. Yes, Hubble had already taken photographs of this nebula, but these stars, shrouded in dust, could not be observed. In the center of the image, you can see the cavity of the nebula and a cluster of massive young stars, which flicker in blue. The cavity is formed by the breath of these stars, which are full of energy, and therefore push back the material in which they were born several tens of thousands of years ago. Around the cluster of young stars, the densest areas of dust hide protostars in formation. Like the images of the Carina Nebula and the Orion Nebula, this image should help astronomers better understand the processes behind star formation. We still have one last image of a nebula to observe. This time it is the Southern Ring Planetary Nebula, also called NGC 3132, or Caldwell 74, released on July 12, 2022. Planetary nebulae are so called because astronomers once mistook them for planets. They are large clouds of gas, created by giant stars at the end of their life, which become unstable and start to eject their upper layers. Planetary nebulae disperse in 50,000 years or sometimes less. This is a relatively short time, considering that dwarf stars like the Sun have an average life expectancy of 10 billion years. The probability of observing planetary nebulae seems very low, but in reality, it is not so low, since our galaxy alone has between 200 and 400 billion stars. We therefore know of more than 1,500 planetary nebulae. The Southern Ring Planetary Nebula is located at about 2,500 light-years from Earth, in the constellation of the Veils. The incredible precision of the James Webb images allowed scientists to see that this planetary nebula is not the result of a single dying star, but of two. Yes, the star in question is part of a binary system. Because the second star is brighter than the dying star at the heart of the nebula, which has become a white dwarf, it is the second star that influences the appearance of the nebula by shaping the gas and dust into asymmetric patterns. The second star is also surrounded by dust, so it will also form a planetary nebula by dying. Scientists are eagerly awaiting pictures from the James Webb, showing a nebula within a nebula. Unfortunately, this star could still live a few million years. We will therefore most probably never have the opportunity to see this phenomenon. In the meantime, we can't get enough of NIRCam's image, which reveals impressive landscapes, arcs of matter, veils of dust, tentacles emitted by the stars in formation. The James Webb Telescope was designed to advance research in several areas. It will help scientists better understand the birth of stars and the mechanisms at work in the formation and evolution of exoplanets. But not only that, one of the main missions of the James Webb is to detect the light of the first galaxies, those that appeared just after the Big Bang. By observing the first galaxies, astronomers hope to learn more about the formation and evolution of galaxies, but also about the universe as a whole. This mission could not be conducted by Hubble. The James Webb, because it sees in the near and mid-infrared, can not only go further back in time and observe the first galaxies in formation, but it can also inspect galaxies and other objects that appear to Hubble, hidden behind thick clouds of dust. To carry out this mission, the James Webb has been equipped with 4 scientific instruments. 3 can see in the near-infrared, the NIRCam, the near-spec spectrograph, and the nearest spectroimager. And 1 can see in the mid-infrared, the MIRI spectroimager. MIRI is complementary to the other instruments and has proven to be of paramount importance. And yet, this instrument was almost never born. Yes, we did not imagine that such an instrument could be possible at the beginning of the James Webb design project, at the turn of the 2000s. At that time, only near-infrared was known. But why is it so important for astronomers to find the oldest galaxies? Because they could reveal things about the cosmic dawn, that very remote period of the early universe, when the cosmos emerged from darkness with the first stars. The Big Bang would have occurred about 13.7 billion years ago. It would have been followed by a long phase of darkness, during which the universe would have cooled. Then, about 100 million years later, under the effect of gravitation, matter would have condensed in some places, forming the first stars, forming in turn the first galaxies. Yes, but how? What are the physical processes at the origin of these evolutions of our universe? These are questions that astronomers ask themselves, and for which they would like to have the answers to better understand the origin of our world. The images and data reported by James Webb have not disappointed astronomers. Even more, these observations have challenged everything they thought about the very first galaxies. Already, the information from the James Webb data suggests that the very first galaxies were formed earlier than expected. In addition, the galaxies appear particularly numerous and luminous compared to what astronomers had imagined. Yes, the astronomers' models had not foreseen that the galaxies were so luminous so early in the history of the universe, and especially that they were so numerous. According to the models, it would have been necessary to probe a much larger space to find as many galaxies of the luminosity and mass of those found by the James Webb. Astronomers have always had a very chaotic view of the early universe, but what appears through the observations of the James Webb are the first galaxies very orderly and very calm. Observations that challenge the current understanding of the formation of galaxies. The current model differs slightly from what was observed via James Webb. Astronomers believe that at the origin of galaxies, we have the formation of dark matter halos. These halos will accrete normal matter, i.e. hydrogen gas, which will condense and form the first generation of stars and galaxies. But such a model cannot explain that so many galaxies can form, and so quickly. Among the old galaxies observed by the James Webb, several galaxies appear particularly bright. They are the oldest already observed, since they were already present 450 and 350 million years after the Big Bang. Jade's GS Z13-0, located at 33 billion light-years from us, would be the oldest galaxy, since it would date from a little over 300 million years after the Big Bang. It would thus break the record of the oldest galaxy, held for many years by GN-Z11, which appeared 400 million years after the Big Bang. But how could Jade's be so far away when the universe is only 13.8 billion years old? With a light travel distance of 13.6 billion years, we see the galaxy as it was 300 million years ago, after the Big Bang. but due to the expansion of the universe, its actual distance is 33.6 billion light-years. By expansion, we mean dilation. This dilation of the universe is such that the speed at which space dilates is greater than that of light. This means that one day, jades will leave our observable universe. Smaller than the Milky Way, these galaxies transform gas into stars very quickly. It is a great mystery for astronomers. How could these ancient galaxies, apparently massive, have formed so many stars in so little time? According to current models, they would have started to form only 100 million years after the Big Bang. Or maybe these galaxies are home to so-called population 3 stars, which are different from the stars you know and observe from Earth. These very first stars remain theoretical. They have never been observed. Another surprise revealed by the James Webb: the ancient galaxies are not irregularly shaped galaxies, contrary to what Hubble's images suggested, but magnificent spiral galaxies like our own. Astronomers see this as an opportunity to better understand the formation of stars. What confirms that these galaxies are still at the very beginning of their evolution are the NIRSPEC measurements, which reveal that the primitive galaxies observed by the James Webb are 100 times less enriched in metals than the Milky Way. However, these metals are forged by the stars. In the top of the most distant galaxies observed, we find Glass Z13, discovered by the James Webb Telescope in July 2022. The measurement of the redshift of Glass Z13 showed that it is located between about 13.4 and 13.5 billion light-years from Earth. This means that if you observe it from Earth, you see this galaxy as it was about 300 to 400 million years ago, after the Big Bang. However, we are still waiting for the confirmation of its red shift by spectroscopy. If it is true, this galaxy is even more distant than expected. Glass Z13 is a protogalaxy. That is to say that it is characterized by a very strong formation of stars. It is small and relatively low mass, with a size of about 3,260 light-years and a mass of about 1 billion solar masses. Glass Z13 was observed by the NIRCam instrument of James Webb. The telescope was able to detect it through the deep field, which is a wider image that was taken with a long exposure time in order to capture the faintest glow. The image was translated so that the human eye could see what was seen by the telescope. Transposed in the visible spectrum, we can observe a red circular shape, rather blurred, with a white center. It is not yet possible to say when Glass Z13 was formed. Astronomers do not understand how such a massive galaxy could exist so soon after the Big Bang. Among the members of the team that discovered Glass Z13 is Peter van Dokkum, who has worked on the enigma of ultra-diffuse galaxies. For astronomers, the formation of ultra-diffuse galaxies remains a mystery. The very existence of these stars questions the theory according to which galaxies are born from dark matter, theorized in particular by the Nobel Prize in Physics James Peebles. According to Peter van Dokkum, the universe was only 2.5% of its current age at the time Glass Z13 was observed. Pending confirmation of the work, astronomers suspect that massive galaxy formation may have begun much earlier than previously thought. Speaking of galaxies, the James Webb Telescope has observed a particularly impressive one, the galaxy M74, or Messier 74, nicknamed Ghost Galaxy. Why this nickname? Because of its low surface brightness, it is difficult to spot. M74 is a spiral galaxy of great design, located 32 million light-years from Earth, in the constellation of Pisces. This means that unlike other spiral galaxies with irregular structure, it has prominent and well-defined spiral arms. It was not discovered by James Webb, but by the French astronomer Pierre Méchain in 1780, and was later observed by Charles Messier, hence its name. Hubble had already ventured to photograph this galaxy, but the images were not very clear. The images of James Webb, released on August 30th, 2022, and recomposed by amateur astronomer Judy Schmidt, who has worked on the largest planet in our solar system, Jupiter, are more accurate. James Webb was able to cut through the interference of gas and dust to produce surprisingly clear images of the galaxy's core. These images revealed some amazing things. In particular, we can see that M74's spiral arms, which house filaments of gas and dust, are winding outward from the center of the galaxy. In the central region, there is a lack of gas. The particularly bright regions are star-forming regions, known as Hill regions. These are actually huge clouds of hydrogen gas made bright by the ultraviolet radiation of the young hot stars embedded in them. In a single image, a wide variety of features can be observed. The oldest stars are the red ones towards the center, the youngest stars are the blue ones in the spiral arms, and the stars in formation are the red bubbles of the hill regions. Impressive. This should give astronomers a big boost in their quest to understand how stars and galaxies form. James Webb also produced impressive images of a galaxy that was already known, but had never been observed so clearly and precisely: the Chariot Wheel Galaxy. This galaxy, located 500 million light-years away in the constellation of the Sculptor in the southern hemisphere, is so named because it is wheel-shaped. The composite image, combining observations from James Webb's MIRI and NIRCam instruments, has provided a better understanding of the formation of this galaxy and a forecast of its future evolution. For astronomers, it would have started as a spiral galaxy like the Milky Way, then collided at a high speed with another galaxy, smaller, which gave it its strange shape. The collision would have occurred about 400 million years ago. In the center of the collision, two rings were formed, a bit like the ripples in concentric circles that a pebble would have caused by falling into water. The first ring in the center is very bright and reveals boiling star clusters, which were hidden by clouds of gas and dust in Hubble's images. The second ring on the outside has been expanding for 440 million years. It is by colliding with the gas around its expansion, which causes a violent compression of matter, that the ring triggers star formation. The incredible precision of James Webb's images also allows us to see the details of other galaxies in the background, which have been scattered over billions of light-years. One of the first images from the James Webb Telescope to be released is that of Stephan's Quintet, a group of 5 galaxies located in the Pegasus constellation, and discovered in 1877 thanks to the telescope of the Marseille Observatory. In this group of galaxies, only 4 out of 5 are gravitationally associated. The 5th and brightest galaxy, called NGC 7320, appears close to the others only because it appears in the foreground of the other four from our observation point. In fact, it is 40 million light-years away from Earth, while the other four, NGC 7317, NGC 7318A, NGC 7318b, and NGC 7319 are 290 million light-years away. The image you have in front of you was created by merging 1,000 different graphic files. It is therefore the most detailed image of Stephan's quintet to date. Among the four associated galaxies of Stephan's quintet, NGC 7319 is of particular interest to astronomers. This galaxy hosts an active galactic nucleus with a luminous energy equivalent to 40 billion times that of the Sun. This energy comes from a supermassive black hole with a mass of 24 million solar masses. As a comparison, the SRGA black hole in our galaxy, the Milky Way, measures a little more than 4 million solar masses. The medium-resolution spectrometer of the James Webb's MIRI instrument was able to give us measurements of the gas near the central black hole of NGC 7319. By measuring the spectra close to the black hole, we observe that the gas is colder and denser in the reservoir of the black hole, i.e. in the gas reserves located at the edge of the accretion disk. We find there large quantities of molecular hydrogen and silicate dust, which will absorb the light of the central regions of the galaxy. These silicate dusts have a composition similar to beach sand, but with grains much smaller than sand grains. In the region near the black hole, the gases are hot and ionized, with the presence of elements such as iron, argon, neon, sulfur, and oxygen. Interesting information for astronomers who will be able, by analyzing these data, to better understand the properties and origins of the plasma flows around the black hole. Thanks to the precision of the images of Stephan's quintet, astronomers hope to be able to study the fusion and the interactions between galaxies. One of the images that made the biggest impression on the public was the Pillars of Creation. You can see why when you see this beautiful image with shades of blue, red, and gray. But what are the Pillars of Creation? The Pillars of Creation were made famous by a Hubble image in 1995. They are a star-forming area about 6,500 light-years away in the heart of the Eagle Nebula, Messier 16. The Eagle Nebula is one of the most productive star-forming areas in the Milky Way. James Webb's infrared vision has once again allowed us to see through the clouds of gas and dust to reveal an area very dense with stars and veils of gas and dust. In fact, on the James Webb image, we see many more stars than on the Hubble image. The stars that appear as red dots are baby stars, only a few 100,000 years old, and the red streaks that can be seen in the dust and gas clouds are nascent balls of gas that will later become stars. Another image captured by the MIRI instrument gives yet another perspective on these pillars of creation, sometimes called pillars of destruction. Why? Because the shape of the gigantic columns of dust is caused by the erosion caused by the continuous ultraviolet radiation of young massive stars. These columns of dust are therefore bound to disappear relatively quickly. On the image produced by the MIRI instrument, we see less bright stars. Indeed, the instrument is only sensitive to wavelengths between 5.6 and 25.5 microns, and stars emit almost no light at these wavelengths. The MIRI image shows only gas and dust, and some young stars, wrapped in their cocoon of gas and dust. We also see some stars that are no longer wrapped in this cocoon, which appear in blue on the image. These more precise images of the pillars of creation will allow astronomers and scientists to update their models of star formation. The James Webb Telescope has also produced beautiful images of Jupiter, its moons, rings, and auroras. Precise images that will help astronomers to understand even better this huge planet that could swallow 2.5 times all the planets of the solar system. This impressive image was made possible thanks to data from the James Webb Near-Infrared Camera, NIRCam. The collected data have been adapted to create clear images, especially for the public. The areas that appear in red correspond to the longest wavelengths, and the areas in blue to the shortest. The mists around the north and south poles of Jupiter have been colored in yellow and green. A reddish filter has been applied to reveal the auroras and the light reflected by the lower clouds of Jupiter, and a blue filter represents the light reflected by a deeper main cloud. Jupiter's auroras are made of charged particles from the Sun, which react to its magnetic field. In other words, these charged particles will impact on the atoms and molecules of the atmosphere, which will emit light in a series of wavelengths that are specific to them. The magnetic field of Jupiter guides the charged particles coming from the magnetosphere towards the polar regions. Jupiter's auroras are permanent, unlike the ones you can see at the poles on Earth. The most energetic ones are born from the projection of matter from the moon Io. Electrons and ions of sulfur and oxygen from the moon are carried away by Jupiter's magnetic field and begin to spin at the same speed as the planet. They accumulate on the orbit of Io before slowly escaping, causing a procession of waves, electric currents, and magnetic reconnections, which create the aurora. A study in August 2021 had shown that these auroras were like a radiator providing heat to the entire planet. As for the rings of Jupiter, they appear dim on the photo. According to NASA, they are 1 million times less bright than the planet. You can also see the winds and storms on the surface of Jupiter in the image. The Great Red Spot, which appears white on the picture because of the large amount of sunlight it reflects, is actually a massive storm big enough to envelop the entire Earth. Yes, as impressive as it may seem to you, this gigantic anticyclone in Jupiter's atmosphere, with winds blowing at 700 kilometers per hour, or more than 435 miles per hour, measures 15,000 kilometers, or 9,300 miles wide, by nearly 12,000 kilometers, or 7,500 miles long. In the past, its dimensions have been even larger. The Great Red Spot was discovered in 1665, so it is over 350 years old. Its color was initially red, before changing over the years to a more brownish hue. You can also see on the image 2 of the 79 moons of Jupiter, Amalthea and Adraste. They are very small and very difficult to spot. Still in our solar system, James Webb has made the most breathtaking image of Neptune's rings in 30 years. Not since the Voyager 2 spacecraft flew past Neptune in August 1989 have we seen such a clear image of Neptune's rings. On September 21, 2022, impressive pictures of the ice giant, taken by the James Webb Telescope, were released. These pictures are landmark, because it is the first time that we can observe Neptune's rings in the infrared. There is another thing that should surprise you on these images. Yes, Neptune does not appear blue, but white-gray. Neptune is blue when observed in visible light because of the methane in its atmosphere. That's why on Hubble's pictures it is blue, while the image taken by the James Webb Telescope in the near-infrared has been colored in white-gray. Apart from Neptune's rings and its intriguing color, the image reveals other surprises. As one of Neptune's poles, we see what NASA describes as strange light. The James Webb Telescope also photographed 7 of Neptune's 14 moons, including Triton, which you may have mistaken in the image for a small star. Yes, even if it seems surprising, the moon Triton is even bigger than the dwarf planet Pluto. It is therefore very visible on the image, especially since it appears as bright as Neptune because of the reflection of sunlight on its surface of nitrogen ice. Because Triton reflects 70% of the light from the sun that hits it. On the images, we can also see the moons Galatea, Naiad, Thalassa, Larissa, Proteus, and Despina. Astronomers have welcomed these images with enthusiasm. Neptune is difficult to image because it is located 30 times further from the sun than we are. Its environment is therefore quite dark. In addition, only one space mission has so far been conducted to explore and understand the 8th planet of our solar system, the mission of the American probe Voyager 2 in 1989. This mission allowed the discovery of Neptune's rings. However, there are still many mysteries to be solved on Neptune, including the strange dark spot discovered by Hubble on December 15, 2020, which could be a storm, but evolves in a strange way. Astronomers would also like to know more about Neptune's moons, which have an unpredictable behavior. In particular, NASA has published a study of the small moons Naiad and Thalassa, which constantly avoid each other in what can be called a dance of avoidance. The 2 moons have a strange orbit, especially Naiad, but they remain linked by an orbital resonance. Most importantly, astronomers would like to confirm the hypothesis that it could be raining diamonds at the heart of Neptune. The next discoveries of James Webb should help us to know more. We're keeping up the momentum with James Webb's impressive discoveries. The telescope revealed on September 2, 2022, the first direct images of an exoplanet located in the mid-infrared outside our solar system. It is the exoplanet HIP 65426b, a gas giant that could not host life as we know it, especially since the temperature of its atmosphere is estimated at 1400 degrees Celsius, or more than 2,550 degrees Fahrenheit. For the moment, we know that it is 6 to 12 times the mass of Jupiter. The data from the telescope should help astronomers to refine this estimate later. It would be 15 to 20 million years old. It is therefore rather young, on the scale of planets, of course. For comparison, the Earth is 4.5 billion years old. HIP 65426b is located at 90 astronomical units from its star. The images of HIP 65426b were the first of the ERS 1387 program, which is dedicated to direct observations of nearby planetary systems. More recently, the James Webb Telescope has confirmed the presence of a rocky exoplanet, LHS 475b, 41 light-years away. This exoplanet has many similarities with the Earth. It could have an atmosphere, and it is 99% the diameter of the Earth. If its temperature is barely warmer than Earth's, it is still a few hundred degrees warmer, which makes it closer to Venus than to Earth. Yes, LHS 475b is very close to its star, LHS 475. It takes only 2 days to go around it. So yes, its star is a red dwarf, so it is twice as cold as the Sun. But the data from James Webb still indicate very high temperatures. Currently, there are two hypotheses. Either LHS 475b has no atmosphere, or it has an atmosphere made of 100% carbon dioxide, against 96.5% in the atmosphere of Venus. Indeed, the analysis and spectroscopy lets think that it is a world without atmosphere. But an atmosphere composed of 100% CO2 would also look like that on the spectroscopic readings because of its compactness. To discover this exoplanet, James Webb was helped by another telescope, TESS, Transiting Exoplanet Survey Satellite. This telescope, launched in 2018, has 4 wide field cameras that scan the sky to measure the brightness of distant suns. He hypothesized the existence of this exoplanet by observing a decrease in the brightness of its star, which could suggest that a planet was orbiting it. James Webb was then able to confirm its presence with the transit method, that is to say, by observing the passage of LHS 475b in front of its star. You may wonder how this planet could have escaped James Webb for a year? Well, it's simply because James Webb's observing time is too precious and his field of view too small to stay fixed on a single portion of the sky for too long in the hope of seeing the planet pass in front of its star, which is called a transit. When an exoplanet passes in front of a star, we observe a decrease in the luminosity of the star, which is already an important indication of the presence of the planet. Further observations during the summer of 2023 should provide astronomers with more answers. Does this small rocky ball have an atmosphere? What is this atmosphere composed of if it exists? Could it harbor an extraterrestrial life form? In any case, the discovery of LHS 475b by James Webb is already hopeful because it shows that the telescope is capable of finding other rocky planets. This photo from James Webb, released in November 2022, reveals the formation of a protostar, L1527, located in the constellation Taurus. The light emitted by this young star, about 100,000 years old, is shaped like an hourglass, hence the nickname, cosmic hourglass, given to this phenomenon. The hourglass is formed by the ejection of material from the forming star. As the material moves away from the protostar, it collides with the surrounding material and creates cavities. In the center of the cosmic hourglass, we can observe the protoplanetary disk, a disk of rotating gas, or accretion disk, which feeds the protostar with material. On the image, it forms a horizontal bar partially hiding the star. According to NASA and ESA, this image of L1527 provides a window into what our Sun and solar system looked like in their early days. For L1527 is in the earliest stage of star formation. It has not yet begun thermonuclear fusion. Astronomers know what happens next thanks to their models, and the observation of L1527 will allow them to confirm it. The young star will gain mass, compress, and the temperature of its core will increase until fusion starts. It is at this moment that a star will be born. We've taken a tour of the major discoveries of the James Webb Telescope. Impressive, isn't it? Astronomers are more than satisfied with the results of the James Webb. Many images were able to confirm hypotheses, and it only remains to go even further in the observation, in detail, to understand even better the birth of galaxies and the formation of stars. The 2023 program of the James Webb is already busy. In particular, the telescope will turn its attention to objects in the Kuiper Belt. The Kuiper Belt is a ring-shaped area of the solar system that extends beyond the orbit of Neptune, between 30 and 55 astronomical units. Similar in shape to the asteroid belt, it is, however, 20 times wider and 20 to 200 times more massive. It is composed of icy bodies that are the remains of the formation of the solar system, including the dwarf planets Pluto and Haumea. The objective of the astronomers is to study the composition of the atmosphere of these objects, in particular by analyzing the solar rays which reflect there. In 2023, the James Webb Telescope will also study the black hole at the center of the Milky Way, Sagittarius A, as well as the Iris Nebula. The Iris Nebula, or NGC 7023, is located 1,300 light-years from Earth, in the constellation of Cepheus. It is what is called a reflection nebula, a cloud of dust which reflects the light of one or more nearby stars. Reflection nebulae are often areas of star formation, hence the interest of astronomers for this area of the universe. In addition, scientists have detected strange phenomena in this nebula. The formation of giant, fullerene molecules, chains of 60 carbon atoms, which is very complex for such a medium. Finally, some astronomers hope that James Webb can provide answers to the famous debate that divides the scientific community between those who believe that dark matter exists and others who, on the contrary, submit new hypotheses. This is the case of the proponents of the Mond theory, who believe that the laws of gravity and mechanics should be modified to describe the origin and behavior of galaxies. The Mond theory, or modified Newtonian dynamics theory, is an alternative to the concept of dark matter, introduced in the 1980s by the Israeli physicist Mordechai Milgrom, and now defended by Stacy McGaugh of Case Western Reserve University in Cleveland, USA. It could explain why the old galaxies detected by James Webb formed so quickly, which the standard cosmological model does not yet explain. The successor of the James Webb is already known. Its name? Roman Space Telescope. This next telescope will be mainly dedicated to the study of dark matter and dark energy, and will succeed the James Webb by 2027. But on January 9, 2023, NASA gave a first glimpse of the future large observatory that could succeed the Roman Space Telescope. It is known under the provisional name of Habitable Worlds Observatory. This large observatory will have a mirror of 6 to 8 meters to see in the visible, ultraviolet, and infrared. It will be capable of discovering habitable exoplanets and signs of potential extraterrestrial life on them. The first mission will be to study in detail the 25 most Earth-like exoplanets. This is the minimum necessary to statistically confirm whether life is common in the galaxy. Technically, the telescope of this observatory will have to be of a very great stability, without common measure with the James Webb Telescope. We are now coming to the end of this extraordinary journey in the heart of the discoveries of the most powerful telescope in the history of astronomy, the James Webb. Astronomers, scientists, and the public alike are far from disappointed with the images and data produced by James Webb. In only 1 year, many discoveries have been made. The telescope has exceeded scientists' expectations and has confirmed the existence of many objects and phenomena that had been theorized. It has also demonstrated its capabilities, including the detection of exoplanets and the analysis of their atmospheres, two crucial elements in the quest for extraterrestrial life that fascinates astronomers. But above all, James Webb may finally be able to provide us with real answers about the formation of our universe. Yes, because the telescope can observe objects that appeared 100 million years after the Big Bang, which would allow astronomers to go further back in the history of the universe, and perhaps one day elucidate the great mystery of the first moments of the cosmos.